NASA has just issued a statement calling on the general public for a vitally important mission to protect our planet from space threats. The American Space Agency is seeking volunteers willing to collaborate on the Space Umbrella Project, an initiative directly linked to the complex Magnetosphere Multi-Scale (MMS) mission. The central objective of this call is to mass analyze data on solar winds and better understand their impacts on Earth, since the ability to predict solar storms is crucial for the safety of our modern technological infrastructure. To understand the urgency of this request, we need to look to the past and analyze the destructive potential of our Sun-Earth's magnetosphere acts as an indispensable shield against cosmic radiation, allowing the development of life, but it is not impenetrable. A frightening historical example is the Carrington event, which occurred in 1859, when a solar storm was so intense that it generated auroras visible even in South America and caused telegraph wires to spontaneously combust. This event serves as a constant reminder that, although Earth's shield is robust, solar energy can overwhelm it with real physical consequences. If a phenomenon of the magnitude of the Carrington event were to occur today, the consequences would be incomparably more devastating than in the 19th century due to our technological dependence. A solar storm of this scale could collapse entire power grids, render GPS systems essential for air and sea navigation useless, destroy communication satellites, and fry globally interconnected electronic infrastructures. This is precisely why an international coalition of emergency experts, astronomers, and government agencies has been formed, focused on expanding knowledge about these events to prevent a global technological blackout. At the heart of this defense strategy is the MMS mission, which plays a fundamental role in monitoring the space environment. Launched with 4 satellites operating in a near-equatorial orbit, the mission is about to complete 16 years of continuous research and data collection. Since their launch, these sophisticated instruments have recorded detailed information about highly energized solar winds and, primarily, about how these particles dynamically interact with a magnetic field that protects Earth. The scientific focus of this mission is to unravel the secrets of a specific phenomenon called magnetic reconnection. According to the mission scientists, this process occurs when the magnetic fields of the Sun and Earth align or separate, resulting in an explosive transfer of energy between them. Understanding magnetic reconnection is key to the problem, as this process is not unique to our planet. It is relevant to understanding the physics of other planets and various regions of the universe, being the mechanism that can trigger the most significant and dangerous effects on our atmosphere. However, the amount of data generated by the 4 satellites over almost 2 decades is monumental, and this is where the Space Umbrella Project comes in. NASA realized that, to process this information with the necessary speed, it needs human help to identify patterns that computers might still miss. The project was designed to visually identify when magnetic reconnection occurs, asking ordinary citizens to help classify the collected data to refine scientific prediction models. The most interesting thing is that the project is extremely democratic and accessible, eliminating the barrier of academic training. To participate in Space Umbrella, it is not necessary to be an astrophysicist or have any degree in the field. The system offers a simple introductory tutorial, after which volunteers analyze spectral images representing 10 minutes of real data. Within this data, a specific 1-minute segment is highlighted, and it is up to the volunteer to classify what they are seeing, helping NASA separate the noise from the critical information. The volunteer's practical task involves the visual identification of space regions based on colored graphs. The participant must determine whether the graph shows the pure magnetosphere, the region known as the sheath, an area closer to the Sun where solar and planetary particles converge, or a combination of both. These differences are identifiable by the color, width, and positioning of the bands in the spectrum, and the project website also offers an active forum and special events to keep the community engaged and trained. To date, the public response has been impressive, with nearly 600,000 classifications already registered on the platform. However, due to the massive volume of information collected by the MMS mission, the project is estimated to be only 40% complete. This indicates that there is still a huge amount of work to be done, and that the contribution of new volunteers is essential to close this knowledge gap, helping to protect our technology and way of life against the next major solar storm.